Hi, this video should sort of serve as a part 2 to the OtterGrader introduction for BLDAP, and also as an accompanying guide to the in-depth workflow for implementing Otter in notebooks portion of the BLDAP OtterGrader notes. Okay. Yeah, so for this example, I'll be sort of modifying a notebook 04, which is our current loops notebook. And as you can see, we have a notebook here. Our first step will sort of be to tell OtterGrader what instructions we wanted to have. So this would sort of be an assignment configuration I have over here. And yeah, you can pretty much just copy it down this exact same format and it should work. Some important things to note are to first, for this demo, put all cells in under raw. And you will not need to have these things. That would be only for VS Code. This should be sort of what we want. And yeah, there should be more instructions in the doc, but yeah, these are some basic configurations that we can use for OtterGrader. So as you can see, this notebook is about for loops, and we have first our first question, which is to multiply every number in the list by 3 and add it to a this called triple numbers. As you can see, we sort of already have a solution over here. As you can see, we have a list and numpy append function, which will end up creating an array of triple numbers. Our first step over here is going to be to input, add in basically 6 raw cells and then also some test cases. So first, we want to wrap our question around with a begin question cell. And like the previous cell, it will be a raw cell. And we can also specify the name of the question. So this is the first question in the notebook, and it will be named Q1. Next, we can add our begin solution, which is our second step. Yeah, and once again, a raw cell. And so we come to our solution. And you might be wondering, how does OtterGrader know what is the solution and what to sort of distribute to both students and instructors? So as you can might remember, what OtterGrader does is it produces 2 versions of this notebook without the sort of the special instructions that we are implementing here. One version will be sort of an instructor's solution, and then another one will be a student version with some blank like cells, like blank text. Like instead of a list here, it might be ellipses, and the student will have to fill that out. And so 2 versions in total, instructor and student. So what we can do here is after an assignment statement, we can add a little hashtag over here, just saying that this is the solution. And what OtterGrader would do is that for the instructor's version, it will just keep the normal brackets, but also for the student version, it will just turn that into ellipses, which is kind of nice, just for telling the student what they need to implement. For this question, we can also do this for here over here. So it will just delete the numpy append function, and so triple numbers will be set to ellipses essentially. Yeah, we should be good to go over here. There are more ways to do this, but this is just the simplest way of doing it so far. Next, our third step is to have an end solution cell. So we'll just add that over here as a raw cell. And then another big part of this is also adding in test cases. So these can sort of range in difficulty, depending on or complexity, depending on how we want it. So in between the begin tests and end test cells, I will have a regular code cell. As you see, it is a code cell, and we will just want to implement some simple assert statements. So for example, we can just say that assert triple numbers let's see, triple numbers first item is equal to 3. Yeah, so that was sort of tell the student, hey, if our first number happens to be, for example, 2. That sort of is wrong, and it should actually be 3. But in order to that might just be sort of a bad idea, because that might just tell the student, hey, this is the answer, and the student will just be able to just set triple numbers the first item to 3, and that'll be that. So in case we want to hide it away, what we can do is one thing is we can sort of add in sort of a hidden test case cell. And OtterGrader will automatically hide this from the student. And we can sort of actually just turn this into a hash string, which is pretty much incomprehensible to humans, I guess. Yeah. Yeah, and so this function will sort of just turn whatever number we want into a hash code. And then so the students will not be able to know what the actual answer is. And then next we can also, I will just copy paste this for now. Assert that triple numbers 0 is equal to some hash code, which we can just sort of quickly test here. Yeah, so with our solution, it should be this sort of string here. And so we will just set it to being equal to this. And see, this might be just sort of an easier way of, instead of the student seeing that the answer is 3, the student will see this random hash code, which unless they know how to change numbers to hash codes, that would not be easy for them to know. And we can also do some other test cases. So for the list, our solution, it ends up being an array. So we want to be able to test the type of the list. So it should be either an array or a list, depending on how they sort of add in their items. And these test cases should end up passing. All right. Next, we also have our end tests cell. And then we also want to end off the question by adding an end question. So as a quick summary to all of this, we originally had one question over here, and sort of our instructions. We ended up wanting to add in 6 raw cells. So our first one is begin question, and then we also have a name. Then we have a begin solution and end solution, which should end up wrapping around the solution that we want. Then we have begin tests and end tests, which should wrap around some hidden tests that students should be able to pass. And then end questions should be able to just culminate the rest of the test. Awesome. Yeah, and so we will sort of want to follow this 6 raw cells pattern for every single question we want to edit. And for clarity, I will just show another question. Yeah, so we have another question over here. Create a for loop that adds only even numbers between 2 and 8. So what we can also do is we can be even more flexible about this one. So I will end up adding the begin question cells. Begin question cell, and this is going to be our second question. Then we also want to add in our begin solution. So, and this should also still be a raw cell. Yeah, so for this one, let's just say we want to be a bit more flexible with how you want to write our code and what do we want to give to the students. What we can actually do is inside this solution cell, we can just write in Boolean solution and end solution. And what this will do is it will sort of just X out all of this stuff. So the student will be able to just, we'll need to be able to create a for loop on their own. And hopefully that should be simple enough. Yeah, so in general, begin solution and end solution is another way of wrapping around our solution for our problem. And it offers a bit more flexibility as we can wrap around larger blocks of code. Yeah, and once again, we'll follow the same process. So we'll have we'll add in our end solution cell. And then also add some more test cases. Yeah, so I'll just sort of copy and paste the same thing that we did earlier. If you would like to copy paste this, it should be still on notebook 04 and under other notebooks. Yeah, and once we will try to hide this away from the student. So yeah, so get hash. Let's just say we want to ensure that the student has the correct even number for this. So the last number should be 8. So get hash 8 should be this sort of string. And then we will have once again we will have our assert statements. So this will be titled even numbers. And we want to test if it's an array or it is a list. And that should be good enough. Then our index 3, which is 8, should end up outputting this weird string if we turn it into a hash code. Yeah, and then we can also test if the length of the string is 4, which it should be. And obviously should once again pass if we want to run this out. Let's see, even numbers. Oh my apologies. All right, yeah, and we can test that this sort of passes. All right, now we're on step number 5, which is just adding in the test case and the end test cell, and then we can conclude the question by just simply writing end question. All right, so now we have pretty much all. I've already done this for the rest of the questions here, but once all of our questions are sort of uh done with OtterGrader, what we can do now is once you have our assignment configuration and we have all of our questions sort of wrapped around, as you can see over here, now we want to head over to the terminal. On CodeCalc, this should be pretty easy. We're already in the correct location we want. But what we want to do now is we want to assign a distribution folder to this. And this will sort of output our instructor's solution and our student solution. Okay, hello. So we're back with the terminal. As you can see, we are on the right path. And what we sort of want to run is sort of command auto assign, beginning with python3.m. And I would like to sort of just acknowledge that we're doing this in a folder that already has all of the images and requirements.txt. What this will do once you run this command is it might have a small warning about strings, but in general, this should be fine. And as you can see, we sort of have a dist folder that has now popped up. Yeah, so what this should have is it should have an AutoGrader folder and also a student folder. The AutoGrader folder should end up being an instructor's version, and it should be able to show you what AutoGrader might look like. So as you can see, it should run, and eventually, yeah. So this is something we didn't have before. We have our initialized auto cell, and it has all of our solutions before. So as you can see, we just went over question 2. Yeah, and it already has our solutions over here. At the very end of the notebook, it will also have our submission cell, which will end up allowing us to output our final result. For the student, the big difference here is that the notebook should run. But for a question like question 1, as you can see, our solutions are no longer here, and the student will be able to use this copy to do their work and put in whatever code they want. Yeah, so I hope this is a good introduction to OtterGrader. And there's a lot of capabilities that OtterGrader can have. So please look at the doc and ask me if you have any questions.